Okay, just to see how I'm getting on, I've replaced these two capacitors here, which were the waxes. They were both leaky. These are the waxes were taken out. I know it's a large capacitor, but the reason why I've done that is because they're a 1000-volt capacitor. I've got them lying around and they're extremely reliable, these capacitors. So I've ditched the waxes. I've replaced two of the electrolytics so far, and actually, funny enough, they seem to have good capacitance still. They could be leaky when they're hot, so they're changing them for a matter of the course. These are the ones that are going to be the most likely problem causing the high distortion on the amplifier, and lack of gain. It will be these are the capacitors that couple the preamplifier to the grid of the push-pull stage. So if there's any positive on the grid, then we're going to get distorted sound. So I'm pulling these out, and it shows the sort of how technology has moved on. That's a 47 nan or 50 nan capacitor rated at 350 volts at 70 degrees. This is a 47 nan rated at 1 kV. Look at the size difference. So what I'm going to do is I'm going to replace that one now with those capacitors, and these capacitors should last forever, really, to be honest with you. They're sort of very understressed and extremely reliable. They won't suffer from the going leaky like a lot of these capacitors do, the early capacitors used to do. So here's one I've reformed earlier. We'll just solder that into place. Got the leads down too short. Got them a bit bloody short, haven't I? It's not a problem. I've got some more of these, but it's nice if you actually cut them down the right length. I'm going to put a small twist in there to hold that in place. Solder that in place on top. That's good. Just stretch these links out a little bit further. So I like to put a little kink on the bottom of these. That's how they were originally. Well, they're actually wrapped all the way round from the factory. They're wrapped around the tag strip a couple of times, which is all very well. That's pretty how they assemble them. They pretty assemble them like that and then solder them afterwards. But it does make them a pain to get out, because you have to take out all the solder because you can't see where the wire goes. So you're sort of fishing around in a sort of a meniscus of solder trying to remove the old component out. Okay, that's good. Let's get this one out. So what I do is I use solder wick. Some people use a soldering pump, but I tend to prefer to use wick. We just wick off the solder as much as we can. Try not to breathe in the flux. Okay. Just bend it with the soldering iron. Just bend the wire once you can see where the end of the wire. Just bend it into a shape where you can pull it off the tag strip, and do the same on the bottom. Try not to keep the soldering iron on the tag strip for too long, because the Paxlin starts to can go a bit soft with heat. You might find the strip falling off. So you try and keep the heat as low as possible, or on the tag strip as short time as possible. See, this is the problem that I've got at the moment. I can't quite see the end of the wire. I mean, a lot of people actually just hack the component off, or sometimes even wrap it to the wire that's existing. I will do it on some radios, but as this is a nice sort of radio, I would like to try and do this as best I can. Burning your fingers. Okay, so that's the other capacitor out. I'll check those later on, but I'm pretty confident they'll be leaky. So reform this capacitor, or when I say reform it, form it so it will fit in the tag strip. Cut the legs down this time, not so bloody short. Okay, and the same again, pop it in, just bend the tag round. I try and get them as central as I can so they're in the centre of this tag strip. It just doesn't, so, you know, it doesn't make any difference to the where the radio performs, but it just looks a little bit tidier if you can get them sort of right in the middle. You've got a sort of like a staggered line of components along the length of the tag strip. I realise I'm waffling a bit, but just doing it to fill up the video really. Okay, so let's solder that. Do the same on the bottom, just bend a little tab around in it so it's got a bit more surface area to hook onto the connection. Just push those in a little bit so they're not too proud. Good. So that's those capacitors done. So I've just got to dig these out. Now these are a bit of a fiddle, these, because if you see the length of the body is actually almost as wide as the tag strip. And on the first one I managed to get it out okay, but I don't know if I'm going to be able to do it on this one. And as you can see, this one's actually leaking electrolyte, so this one's going to be a problem. Electrical problem anyway, so I'm going to cut the wire off. Oh, this one's actually got corrosion on the joint, so this one's obviously been leaking electrolyte for quite a while. So these capacitors, this end here, the black end is actually the negatives, and the positive end is on the other end. You can see here, this is the positive end and that's the negative. They're not marked, and I couldn't find any information on the internet, but the easiest way I did was put a power supply across them, set to a couple of 100 milliamps current limit, and see which way it draws most current. And it's more or less a short circuit. It's, you know, you've got it around the wrong way. So let's get the solder off this. Now the next thing we'll have to do after these two capacitors here, and find a way of possibly putting an extra tag strip in to bypass this electrolytic, or I might even try and dig out the insides and restuff it. Actually, I wouldn't normally do that. I find that sort of, usually I've got patience for things like that, but as I say, so this is a nice radio. I think it's worth spending that little bit more time getting it right. I've also got to do something about the cabinet. Probably have a go myself, but I'm not so sure I'm going to be able to do anything myself, so I might have to send it off to someone to be repaired. So try and get this capacitor off without unfortunately, because the component's so large physical size, there's not a lot of room to work in here to get the get at the joints, but I think I'm going to have to cut this one. It's not going to come out very easily, this one. Just cut the capacitor off and then just cut the little tab off. There it goes. Shake that out in a minute. Let's do the top one. You can see that. Might just pull it out when it's hot. And nearly off. Good. Okay, let's clean that up a bit. I would suggest if you are starting new doing this that you buy yourself a radio you're not going to damage, because this is a bit of a tricky operation working with tag strips. I know I've damaged lots of radios in the past by breaking tabs off and or losing my temper because I couldn't get the component off, so it's well worth practicing on something that's not worth a lot of money. So okay. So these are 47s and the originals were 50, which is the standard exchange you'll make. You won't get 50 microfarad capacitors anymore. They went over to a different sort of like a different standard. They used to be a sort of 50, 80 microfarads, things like that. Now they're all sort of 47 and 82 and things. So there's no point hunting around for the exactly the right value, because the capacitor tolerance is usually 20% or something like that anyway, so it really doesn't make a lot of difference. This is non-critical really. I don't know what this particular capacitor is, but a lot of them are cathode bypass, and really anything in the range of sort of 22 to 75 microfarads will probably make very little difference to the response of the valve. It's just like effect of a negative feedback. It just gives a slightly better base response, certainly on the output valve, with a larger cathode bypass capacitor on. I want to keep this as close to standard as possible, so that's why we're using 47. Okay, that's that one in, so there's one more to do, and I've only got 14 minutes on this video, so we're against time now, so this one's going to be a bit more awkward because it's got this 2.2 or 220 ohm resistor in the way. So what I'm going to try and do is get it out from behind the resistor, and then maybe, because I don't think I'm going to unsolder that very easily, because it's pretty intertwined with this resistor here, so we can just loosen anything off. No, I've broken the wire off trying to pull it off. So what I'll do is I'm going to wrap that straight round the tag. I don't want to really take that resistor off. I don't want to change any components unless it's absolutely necessary. I will check these resistors for value. Someone suggested that a lot of these resistors will be off. We'll have a look at that, and if they are, obviously we'll change them. These sort of ceramic capacitors, they're fine, as are these. These are very reliable. It's only the waxes and the some of these sort of electrolytics usually are the ones that cause problem. Right, so this lead's got to be quite a bit longer on this one. So I think Trying to get the leg of the capacitor round so it's not going to touch the adjoining contact on the tag. So trying to shape it so it's got quite a sharp radius on it. That's better. That's good. So we'll solder that in place. Needs quite a bit of solder there to hold it in the correct place. So, good. That's the top held in place. We can just form that to make it look tidy, and then just come round. Capacitor's a bit low actually. I need to redo that. Bring the whole capacitor up, body of the capacitor up slightly higher. A bit better, a bit more. Trying to make it look as tidy as possible. Unfortunately this one's not going to be quite as tidy because the way it's around the outer diameter of the tag itself. Let's come around here. Turn that down a bit. Like that. Okay, so that's the final capacitor for really the RF section. What it basically leaves me now is with the power supply, and I'll do that off camera because you don't really want to see me. I'm pretty bored already watching me do all these capacitors. There is one capacitor that needs resoldering, I remember. Where was it? This one here. Resolder that again. Okay, well anyway, that's basically the caps are more or less done. So I'm going to do the power supply and then we'll do a power up and see how it goes.